All right, now that we know how to graph piecewise functions, we're going to look at how to evaluate piecewise functions and then also how to find the different characteristics for them. So first, if we're evaluating piecewise functions, we have to be really careful because they have different pieces, and each of the different pieces have specific x values that you're allowed to use. And so when you plug in a number for x, you don't plug it into all three. You have to plug it into one of them. So if we want to plug in -6, we have to think about which one represents -6 on the graph. And since -6 is less than -2, that means we're plugging it into the first one. So I'm going to say -6 plus 3 cubed. And I want you to actually write that out. Don't write the answer, write the whole thing, because I want you to know that you plugged it into the first one. So -6 plus 3 is -3. -3 to the third power is -27. If we plug in -2, I can see -2 in two places. But if I look at it, this one says that you do not equal -2. This one says that you do equal -2. And so that means that -2 gets plugged into the first piece. So -2 plus 3 cubed would be +1 cubed, which is just 1. If I wanted to plug in 0, 0 is between -2 and 3, and so I'm going to plug it into this piece. So I'd say that's the square root of 0 plus 3, which is just square root 3. You are welcome to leave that as a radical, or if you wanted to plug it into your calculator and find the decimal, that would be fine as well. F of 3, so I am looking here, I can see the 3 is in two different places. Here it does not say that it equals 3, so I'm not going to use this one. This is where it can equal 3. And if you see here, it doesn't have an x for me to plug the 3 into. It's literally just always going to be -2. And then 100 is also greater than 3, so 100 is also going to be -2. Okay, so domain and range. With the domain, I have a left arrow and a right arrow. And so I can see like, okay, it feels like it should probably be -infinity to +infinity. Because these graphs are not continuous, I need to check and make sure that all of the x values in between are getting used. So I can see that all of these x values here are getting used. None of them are being skipped. And then I get to 3, and then I think, oh, 3 might get skipped, but 3 is down here. So we are using an x value of 3, and then we're using all those x values. So I'm going to go ahead and say the domain is from -infinity to +infinity. We did not skip any x values in between there. So that's the domain. The range is from down to up. So this graph goes down forever. So I'm going to start with -infinity. It does not go up forever. At the very highest, it looks like... well, it goes up to right here. I'm going to have to plug a number in and actually see what that is. So I'm going to go ahead and, oh, when I plug in 3, well, right here, it's this point. I need to figure out what this point is right here. So this is an x coordinate of 3, and it's a y coordinate. It comes from the square root graph. I can see that it comes from the square root graph because it's the middle piece right here. So this is the first piece right here. This is the second piece. That's the third piece. So I'm going to go ahead and graph this one. And I'm going to look at the table. And at 3, the point is 2.449 or 2.450. Or if I wanted to, I could go ahead and actually graph it. Let me change my window back to normal. I could actually graph it, and then I could say, okay, at an x value of 3, tell me what the y value is, and then I could see it that way. So you can get it from the table, you can get it from the graph. And so I would say the range is from -infinity up to this y coordinate, which is 2.450. I'm going to put a parenthesis there because that's not filled in. Now, I didn't look at this part at all because that's just a y value of -2, and that's a y value of -2 over here as well. So that didn't really help me on the problem. Okay, so domain, range. Increasing interval. I'm going to go ahead and put my stick figure. So starting at negative infinity, my stick figure is increasing, 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 walking up a very steep hill. And then he levels out for a split second before he starts to walk like out of a valley. And then when he walks out of the valley, he gets like over the cliff and then is walking up a steep hill again. And he gets to 3 and then falls through that hole and is gone. So we have an increasing interval from negative infinity to 3. And then we have a new stick figure that starts right here. And this stick figure is not increasing. And this stick figure is not decreasing. So I'm going to say this is none. And then on my notes, I'm going to go ahead and add another interval. This is called constant. These don't happen all the time. They just happen sometimes, which is why I have not asked you to look for it before. But constant is like saying the stick figure is walking on flat ground. So the stick figure starts at 3. He's walking on flat ground all the way to infinity. And so we're going to say the constant interval is from 3 to infinity. Okay. For the max and for the min, we're looking for like a mountaintop in the picture. So if you need to write this on your notes, you can. A maximum would be a high point of a picture. It could also be kind of like that, something like that. A minimum is a low point for the picture, or it could be like this. And so in this picture, even though there's some curves involved there, I don't see something that's a high point, like where it's the top of something. So no max, no min. Intercepts, we're looking for an x-intercept and a y-intercept. And so I can see the x-intercept is right here. It is the locator point for this cubic piece of the piecewise function. So the x-intercept is negative 3, 0. That's a point, negative 3, 0. I'm going to say that's for the x. And the y-intercept is on that square root graph. And so I'm going to go ahead and do second trace. Number 1, plug in 0, 1.732. So the y-intercept is 0, 1.732. Okay, so we've got our x-intercept, we've got our y-intercept. Is the graph continuous? We're going to say no, because if I trace this, I have to pick up my finger. So I'm going to say not continuous. Okay. And then for end behavior, I'm going to say as I look at the left arrow, as I look at the right arrow. Okay, so as I look at the left arrow, I can see that y is going down. So the left arrow is going down, y goes to negative infinity. This one is very interesting. We've never seen one of these before. As we look at the right arrow, the y value is not going up, it's not going down, it's actually going straight to negative 2 because it never adjusts. It just goes flat the entire time. So we're going to say y goes to negative 2. It's a little bit different from what we had before. Okay, so real quick, I want to show you guys how to graph a piecewise function in your calculator. So if you hit the y equals button, we're going to type in x plus 3 cubed, right? And then after this, you're going to hit a divide by symbol, like slash. And at this point, we're switching from graphing and we're thinking a little bit more in terms of computer programming at this point. So now I'm going to put a parenthesis and I'm going to say if x is less than or equal to negative 2. So I'm going to put an x. And then I'm going to hit second math. So that was second math. And I'm going to go down to 6, less than or equal to negative 2. And if you graph that, you're going to see it was just this little piece of the graph right here. I'm going to go ahead and change my window. If you can see what I'm doing right here, I'm changing the window to match the graph paper that I have. Okay, so I've got, there's the cubic right there. Now I'm going to go ahead and graph this one. This one's a little bit more interesting to type. So I've got square root x plus 3. and then I'm going to hit the slash, and now I'm kind of like computer programming instead of typing in a calculator. I'm going to say x is greater than -2, because if you can see the x, it's got the bigger side towards the x. So I'm going to say x, second math, x is greater than -2. And then I'm going to say second math. I'm going to go over to logic, and I'm going to use the word and. So I'm going to say x is greater than -2 and it's less than 3. So even though it feels like you should be able to put this over there, the calculators typically don't like that. Some of you guys with newer calculators might be able to type that, but I know for sure that mine does not like it. Okay, so x is greater than -2 and x, second math, is less than 3. Okay, so if we go ahead and graph that, now that's the next part. So we've got this little curve here up to there. And then if I do the last piece, I can say -2 and put the slash. Now I'm programming, put a parenthesis, x, second math, is greater than or equal to 3. And there's the rest of it. So I can see that piecewise function. Now what's kind of cool about this is you can hit second graph, and it will tell you which piece you're kind of allowed to plug numbers into. So if you're plugging in -6, you're going to say, oh, I can plug it into the first one and I get -27, like we got. I can't plug it into the second one. I can't plug it into the third one. If I want to plug in -2, I can't plug it into the third one. I can't plug it into the second one, but I can plug it into the first one. I get 1. Or we could go down here if I want to plug in 0. I can't plug it into the first one. I can plug it into the second one. I get the square root of 3, which is 1.732. So that's something that is kind of cool about it. All right, now if you're using one of the color calculators, I could see a real benefit in typing it that way because each of the different pieces would be a different color, so that'd be kind of cool. Or if you want to type in a piecewise function, you can hit the math button and then go up to piecewise. And we have 3 pieces, so I'm going to press OK, and then you can just type them in. So these new calculators are a lot easier to type. And I have looked it up, and we are not allowed to get this update on our other calculators. So this is kind of like if you pay for the color version, then you get some extra tricks here. Oh, second math. Actually, let me go back. X greater than or equal to 3. I'm going to try it this way. We'll see if it lets me do it, and if not, then I'll go back and fix it. Less than x less than 3. So if you have a color calculator, you should be doing this. If you don't have one, you can just get rid of the video right now. You can stop watching. So less than or equal to -2. We'll see if it graphs it. Oh, so tricky. So see, the color ones are a little bit more updated, and so they can handle this notation, whereas the older calculators don't handle it as well. So if you have a color calculator, then it's really easy to plug it in to check your answer. Or if you want to be able to see the 3 different pieces at once, you could type it in this way, and then you can see the 3 pieces. Now, the interesting thing about this that's really cool about the color calculators is that they have everything in one Y value. So you don't have to think it through. You can really just look at that one table and see all the answers, which is pretty neat. So you definitely still need to be able to do it by hand if you have this calculator, because it's fair for me to ask questions like this on a no calculator test. However, this is a great way to check your work as you go and not even have to get up and look at the answer key.